Okay, so let's now discuss the concept of directory. As you might have noticed, I prefer to use the term directory instead of folders. Now let's try to understand why, and we'll also try to understand what is that dot and double dot notation. Though I'm not going to get into the details and each and every exact technical aspect, but I'll try to make you understand what it is. First of all, many people have this concept like directory is like a container, that when you copy a file into the directory, the file is being picked up and placed into that particular container. When you create a directory, a container is created where you put in something. So that concept itself is wrong. So what exactly is a directory? Let's try to understand with this interesting diagram which I have made over here. So this white space you can consider as my partition. Okay, so partitions you can consider as a container on your hard drive. Partition could be considered as a container. So let's say this is one of my partitions where there are some files and there are some directories. Okay, so now inside this you will not see any kind of further containment or this thing. That is a kind of logical representation so that you can easily manage your files and subfolders and make a structure out of it. So what exactly is a directory? Fine. So directory in itself is a file. Now that would sound weird, but that is it. So you can roughly compare a directory to the index page of any book or anything, where there is a list of entries of the chapters. Fine. Which chapters are in this particular book? You can say something like that. Fine. So you will notice that there is the name of the chapter and then it points out to some page number over here. And when you travel to that page number, you can get the contents of that particular chapter. So you can try to understand is that whenever you create a new file, you download a file, it gets stored somewhere on your partition. Fine. With some file name and other kind of aspects are there. On a Linux system, there is something called as a inode, and that inode basically has a lot of information of the file. And one thing you can say that it also has the basic information of where the uh, file is stored. So when you copy a file, let us say this file is say X, this file is Y, or this file is Z. Fine. It gets stored somewhere. Now in your partition on the root level, the root directory itself will have some entries, and let us say these three files you copied in a directory called as A. Fine. So what is going to happen is this directory file will have the entries or the location of X, Y, and Z. Fine. So whenever you will say change to this particular directory, this directory contents is loaded into the memory for your work. Fine. Then when you list this directory, you get the list of the files which belong to this directory. This is a rough understanding of what I'm saying. So directory contains the entries of the files which belong to it. Fine. Similarly, you can say that this file P over here is part of the directory B, and this Z or this file, let us call it M, is inside B. Now very interestingly, the B directory itself belongs to A. It's a subdirectory of A. So A has an entry about that B is a subdirectory over here. Fine. So you can roughly say that files which belong to a particular directory, their entries are inside the directory and they use the information provided by a inode number. Fine. So this is fairly simple, that which file belongs to a particular directory. The file could be anywhere in the partition dependent upon how the operating system is reading writing. Again, not getting into that complexities, only it is simply listed that these files belong to it, and when you list it, you get the reference to the file where it is from the directory entry. Fine. There may be other things, again I'm saying that don't get into that. So we just come to know where the file is, and then we can further access the file with respect to the entry available in the directory. So very interestingly, when you move a file, let's say you move a file from A to B, the file never changes its location on the hard drive until unless it's moved between partitions. It will remain over here. If you remove this entry from here, then this file, if you are moving the file, this file simply gets added as an entry into B. Fine. That is how the moving takes place within the same partition. Okay. Now the question is that for files it is simple, the files belong to it. But when we talk about directories, how this relation is maintained, fine, you will notice that the parent directory has an entry for B. Okay, B is also a file, so it will have its own inode representation and whatever is required. So A has an entry for B. So when you change to the directory A and then when you change to the directory B from A, we will find a reference to B. So once you have changed to the directory B, okay, how will you refer to the parent directory? Because B is obviously not going to have an entry of A. B is just going to have the entry of the files and subdirectories which belong to it. This is where our dot and double dot notation comes into the picture. Every directory, fine, has a reference for itself which is represented by dot, and there is a double dot entry which has the reference to the parent. So let's have a look at this, what I'm trying to say with an example of these entries. So that if there is an entry, say there is further subfolder or subdirectory C, it will have a dot and double dot entry. The dot entry will be a reference to this, double dot entry will be a reference to B. B having the dot and double dot, dot will be the reference to B itself and double dot will have a reference to A itself. So let's have a look at it. I have created some set of directories. So let's log in into our system again. Okay, so let's start with this example. I'm going to do a ls hyphen r, r which is for recursive, and I for inode numbers for the current working directory, and we will see that inside this I've already created a directory foo whose inode number you can notice is 566.240. Inside foo is a directory called as bar whose inode number is 566.241, and inside bar there is a directory called as bash whose inode number is 566.242. Fine. So luckily we got consecutive numbers over here. Now the visualization or understanding is that this directory is inside this directory is inside this, but in fact the reference is used with the dot and double dot representation. So let's first go to directly to this directory bash. So foo bar and bash. Okay, now inside this I'm going to do a ls hyphen ai where you will see the entry for dot and double dot. Now we are currently in bash directory, and the dot, as I mentioned, is a reference to itself. So if you notice over here in this particular line, the inode entry for bash is 242, 566, 242, and the dot represents 242 over here, 566, 242. So the inode entry of bash itself is this, and bash has an entry 566, 241, which is double dot. This double dot, as I said, is always a reference to the parent. So parent of bash is bar. So if we go to bar, you will notice that the bar's inode entry is 241, which is the double dot entry in bash. So bash in itself has an entry who is my parent. Fine. So parent is pointing to the child, that this is my child. Now the child has a reference to its parent from this double dot entry. Now if we come out of this, fine. Okay, see, I'm using cd dot dot now. That means I want to change to the parent. So it changes to bar. And if I do a ls hyphen ai over here, you will notice that the dot entry inside bash is 241. Okay, this dot for, sorry, not, we are not inside bash, my mistake. We are inside bar. Fine, we change to bar. So the dot entry over here is 241, which is same as here the entry for bar, and the double dot entry will be the parent of bar, which will be foo, which is 566 240, which is double dot, and which you can see is this. You can further continue towards the parent and you will reach the top level directory where you will see the dot and double dot entries working in the similar manner. So this is basically how the structuring for folders and subfolders or directories and subdirectories is created. So it's not a concept of a container where everything is inside that you copy a file which goes into that. No, directories are files which has the reference to the subfolders and subfolders and files, and the subfolders have reference to the files which belong to them. The files are placed anywhere on the partition, fine. That is based on some algorithm which is followed by the operating system, but they are not like containers. And that's why the term directory is much more sensible, because directories usually has an entry and a reference to the address where something is located, and directories don't contain everything into that. So the concept of folder is where everything is inside a folder is not correct. Okay, so hope you found it interesting. This was the overview of dot and double dot, and how the dot double dot reference is used in a path concept or with any command, and how it works.